The kind of work that we do now cannot go on without industrial collaboration. In point of fact, the percutaneous heart valve was something that industry brought to us, and we worked on with them. The lines continue to be blurred in the most magnificent way between science that goes on in an industrial setting and an academic setting. And it occurs across the entire spectrum of the careers of students. Students get to work hand in hand with industry on the realization of endless potential of new ideas. And then they increasingly choose to go to industry because they know that industrial partners have resources that even we don't have at a place like MIT. MIT, in turn, can provide assets that industry doesn't have. It can provide people assets, this constant source of brilliant young minds, and then in turn bring in ideas from very many other unrelated disciplines to create these hybrid combination products that are increasingly becoming the transformative technologies of the next decade. We worked for years on the basic biology of the cell that lines blood vessels, the endothelial cell. We worked with some of the great minds in this field, people like Morris Karnofsky. And we began to understand the breadth and depth, the dynamism of this cell. It became evident to us as well that there might be a way of harnessing the power and potency of those cells for therapeutic purposes. But it would require a mastery as well of means of engineering them, of creating material constructs that could house the cells, transport the cells, allow them to remain viable on a shelf for months to years, and then to be placed in confined spaces while still retaining all of their biology. It required a sophistication in material science, but also in cell and molecular biology. We needed to understand when the cell was preserved in its state or perverted. And then we needed to know how, when we inserted the construct, it induced the changes we wanted them to achieve. Today, I'm proud to say that a very fundamental idea about endothelial cell biology has made its way into patients in 5 clinical trials to combat, first and foremost, arterial disease, but increasingly as well, the potential for combating metastatic cancer.